this page or whatever below it goes with number 23 on the final exam and on the packet that you were given with multiple choice. So you have to do number 23 tonight or when we get done. Okay? So, exponential parent function. So, an exponential growth function is when that b value right here was greater than 1. So, if I have 2 to the x power or 5 to the x power, I'm growing. I'm exponentially growing. However, if it's lower than 1, we're decaying. So maybe you remember that, hopefully. Growth and a decay. Here's the decay, it's going down. Here's the growth, it's going up. So let's talk about what that means. There will be a question like this on your exam. Determine if the following function is growing or decaying. If you do not know, by looking at this, please, for the love of God, get out your graphing calculator and type each of your multiple choices in. If you type them in your graphing calculator, you will see if it's growing or decaying if you just don't know off the top of your head. Yeah. This one? Yes, it is going to be decay. And here's why. The 4. What does a negative exponent do? We talked about this yesterday. What does a negative exponent do?
It moves it to the denominator.
It moves it to the denominator. So technically this becomes 1 over 4 to the x power. And because it's now 1 over 4 to the x power, we are going to be decaying. Because 1/4 tells me that I'm decaying. You need a pencil? I just thought you were asking for a pencil.
No, it's okay.
I just didn't know. I thought you were just looking for that kind of pencil. Yeah, I'm like running low. Okay, look at this next one in green. 2/3. There's no negative exponent, so it is what it is. So 2 over 3, is that bigger than 1 or smaller than 1? So we are decaying. This one here in green, 5 over 2, is that bigger or smaller than 1? Bigger, so is it growing or decaying? Growth. Here, it's decay because why?
The negative x is switching it.
Very good. It becomes 4 over 7 to the x. Because it becomes 4 over 7 to the x power, it now is decay. So that negative exponent is crucial. If you do not know that, be a good test taker. You guys all have access to a graphing calculator if they're available to you. You also have those over there if you really need them. You plug them into your y equals, and you can see if the function's growing or decaying. When in doubt, plug it in the calculator. You have 35 questions in a very long time. Plug them into the calculator, huh?
What day is that test on? The first day of testing, right?
You know where I put that information?
Yeah. It's 135.
Right here. So if you were absent, remember I put your final exam schedule right here on the back of the first sheet. Okay, there's your final exam schedule. Thank you, Chris. All right, half-life. So this is when we did like fun things in regards to like applications. So half-life is when we talked about like drugs and how it can decay in your body and that kind of thing. Caffeine, alcohol, things like that. So a new soda contains 60 milligrams of sugar. Whoopsies. That's your initial amount. I gave you guys the formula broken down. A sub 0 is 60 milligrams. The sub 0 just means where you're starting. A lot of people are like, well, what does this 0 mean? What does that 0 mean? It doesn't mean anything. It's just telling you that's your starting point. It's just a notation. So some people like multiply by 0. Don't do that. The half-life is 3, so that's your H. Now your time is the time that you go from 12 p.m. to 9 p.m. So think, on a clock, 12 to 9, how many hours is that? 9. Sometimes it's a little harder. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so now we can just plug it into that formula. Here we go. Remember, my formula is coming from here. I have 60 times a half, because it's a half-life. And then I have 9 divided by 3 in parentheses. And put that in your calculator and you're going to get the answer. Take a minute. Do not shout out the answer because I want everyone to type it in. Because you're going to have to type it in on the test, not me. Final exams, I really don't do much. I know that during the test I sometimes answer questions. Final exams, I'm done. Like, I'm there for support if you don't understand what it's asking, but if you are confused, I will not help you. Because I gave you a lot of time to study with me. Yes, what'd you get?
90.
90, is that what you guys got? I don't think it's 90, because why would 90 not make sense? Can you tell me that?
Because it's bigger than.
I'm so confused.
No, it could be a calculator. So Jacob's got it over there.
It's bigger than on the side.
So Tommy, I just want you to be a good logical person, because in the real world you're gonna have to have logic. Okay? Because look, if I only start with 60 milligrams of sugar, there's no way I can have 90. I'm not gonna produce 30 milligrams of sugar. What'd you get?
15/2.
Yes, which is 7.5, right? Yeah. So 7.5 milligrams. Questions? Flip when you're ready. A lot of you don't have a calculator. It's very hard to do math without a calculator, especially today. Today you need a calculator. There's no option. Tommy. You got one? Got one? Got one? Got one? You over there? You got one? Okay. Okay. There is a compound interest on there. This one is extremely important in general just because you will have, in some time in your life, have to open a bank account and you're going to develop interest, which some of you might even have it now. And it's going to compound a certain amount. When you go and open up a bank account, they'll tell you how many times they compound it in a year, and you can figure out how much money you're going to make over time, which is not going to be a lot, I'll tell you that. But you'll be able to do that if you would like to. When I say annually, how many times a year is that?
Once.
Okay, what about semi?
2.
All right, Jacob, you're closed. Quarterly.
3. 4.
Careful. Quarterly is how many quarters are, 4. Monthly
12.
and daily. 365. Technically 365.24, but we won't go there. 365.25 because of the leap year. But we're just going to use 365. Okay. If you have a bank account whose principal is 200, so that's our P.
That's 2,000.
Sorry, 2,000. Thank you. Quarterly. How many is that? 4. What is that? What part of my formula is quarterly? Is it there R, N, or T?
The N.
The N. So N is 4. I'm going to put that there so you know where it's coming from. My rate is 2.5. But how do I write that as a decimal? Because right now it's a percent. I need a decimal because you can't work with percents in your calculator. 0.25 is 25%. 0.025. You either need to divide it by 100 or you need to just know to move the decimal place over twice. And then 2 years, that's our T. So T is 2. So you have all of the pieces. The hardest part about this formula is putting it in your calculator, in my opinion. But let's go ahead and plug this in. I have 2,000. A equals 2,000. 1 plus my rate, which was 0.025. All over my N, which was 4.
What was that, 1T?
1 plus.
Can we just put 0.025 in the bracket?
You could put 0.025, yes. And then our N, which is 4, times our time, which is 2. Now, so many ways that this can go wrong in your calculator depending on what you have. I would put this in parentheses and this. If I were you, this is how my brain works. Why try to mess things up? Orders of operations. Sometimes I just get all the pieces first. Okay, what is that? Then what is this? And then I put it all together. Sometimes when you try to put it all in at once, things get a little complicated. Obviously, if you know how to do that, great. Then put it all in at one time. But when I work with calculators, I know that there's a lot of errors because I've worked with them for so long. But the blue pieces you can do before you even start the problem. That's just me. Now, would you expect to have less or more than $2,000 in your account?
Less.
More. Why?
Because it's bigger than 1.
Because you're going to be compounding interest. And anything with interest, you're gaining. You're gaining money. Okay, so you're not decaying like we were for half-life. Half-life, you're decaying, and here you're going up. So what'd you guys get? Don't go it to you on the graphing calculator if you need it, which most of you probably do, because this is the hard part, is putting it into the calculator. All right, so I have 2,000, parentheses, 1 plus, parentheses again, 0.025 divided by 4, close it up, caret, brings it up on top, 4 times 2 is 8. I just do that in my head. Why even make it more complicated? 4 times 2 is 8. And then I get, ooh, we are a little off. You gotta check your calculator, my friend. What'd I miss? I didn't miss anything. I wonder how you got 5.3. Do you have it still up there? All right, I'm gonna come see it. You need to put parentheses around it in the calculator for your calculator to understand it.
See, it's the first time I'm not right against them now.
I'm just annoyed because I'm helping you for your final. Okay. So, any other questions? Okay, you have 34 too. That goes with 34. Then you have 32, 33, and 35. This is the next group. So there's a lot of questions on this one formula. So I would really focus. There are 3 questions on your final with this formula. 3 questions. So that's important because think, 3 out of 35. That's a good amount of questions.
So 34, 32, 33, 35.
32, 33, and 35. There are 3 questions on this one formula that we're about to do. The population growth and decay. The reason why is because of the E. That E is super important, especially if you're going to go into physics at all in the future. Physics, you're going to see this exponential, this constant of E. Just random. I want to see if anyone remembers this, because that would be impressive. Does anyone know what E is, what the constant is? It does keep going, but you know how pi is 3.1415926? So E is something. What is it? It's a number. It's just something that keeps going and going and going and going.
It's kind of like pi has infinite constants.
It's irrational. I just wanted to see if anyone remembered, because I mean, I would never ask you to know this. I'm just wondering because we talked about it.
2.
Point.
5.
Nope. 2.712 something. Okay, but you were close. So E is actually a number. I want you to understand that. E is like pi. It's still a number. We just represent it with, huh? What'd you say?
Yeah.
Yeah,
Oh, yeah.
there is. I'll get there. All right, so here we go, one by one. This one question, here we go. Phone. Away.
Me?
In 2015, the population of Homer Glen was 30,200, so that's my initial amount. Please know, and this is actually accurate because I did take it off of the website.
There's 30? Wow.
Yeah. In Homer Glen, it's a lot of people. It is projected the population will grow continuously. When you see grow continuously, that really means the E. That's what the 2.71 is. At a rate of 1.4%. So what is my decimal?
0.014.
Good. My rate is 0.014. What is the anticipated population of Homer Glen in 2030? So I'm going to highlight these 2 pieces. If you don't have a highlighter, maybe circle them, put like a line, so then they go together. In order to find the only other piece you need, which is T, your time, how much time has gone by from 2030 to 2015, which is 15 years. So I wrote it out for you just the way so that you can look back and say, well, how did we get 15? Oh, I got it from subtracting the 2 years. So now we're plugging it in. It's a very easy formula. 3 questions on it on the test. 2 of the questions on the test, which you'll see on your packet, it's super easy. You just plug it in. You don't have to find anything. We give you everything. But one of them you have to do just like this. What's my initial population? 30,200. Okay. E is, again, you have to put that in the calculator, and I will remind you how to do that in a second. My rate, we're just plugging in, and it's going to be 0.014 times 15. And I put parentheses just in case. So now I'm going to show you how to put that in the calculator. Please pay attention. I really do not want to have to repeat how to put E and how to find E, because I'm going to do it right now. So everyone with your hands, have a calculator please in your hand. If you have a nice graphing calculator, it'll be easier for you, because it's going to be this E button right here. See it? It's a little guy above the LN. You have to press second, which is in red right now, and then the LN button. And now I have E. That's how you find E.
Does it matter if you put parentheses in afterwards or
It
not?
depends on your calculator. Some calculators you need parentheses, some you don't. So I'm just going to type in 0.014 times 15 and press enter, because I did mine a little backwards, and that's okay. I'm here, but now I got to times it by 30200. You could have put it all in at once. I just forgot to do it in the beginning, so I'm going to do it at the end. So times 30,200, and you should get, bless you, a bigger number, which
372. Oh, I
yes, you did. You did 372.
I got 3782.
I'll have to come and check it out.
0.
People, now if you have a not so pretty calculator, but these are really nice calculators, they're still TIs.
I didn't get that.
We'll have to figure it out. So right now, with these TIs, because you got this right, Chris, right? So type it in. If you have these, I would recommend using these or those. They're really good calculators, these two. Type in, here we go, 3030200.
Yeah.
30200. Your E button is right here. You see it if you're using this calculator? You might not have the same calculator for the finals. First come, first serve. So you need to learn these as well. I'm not going to show it to you. You got to find it. I promise you it's always going to be there. You just have to look for it.
37.
So I have to press second, the blue button in this situation, and LN, and then 0.014 times 15. Close up the parenthesis, and you get the same thing as me.
I got it.
Okay? You know which ones to work on, so work on them. Press the timer.